Welcome everyone to today's video. On one of those Linux and open source news sites there was a newsworthy news the other day about faster audio decoding and encoding coming to OGG and FLAC. They write here about a whopping 5 up to 10, if not even 15% faster. As we love newsworthy optimizations, especially audiophile ones, very much, of course we have to give this a try. And of course, to measure such improvements by such a huge margin, we need a matching system to test this. And of course I noticed that my viewership loves the Sgi Octane very much, so of course we will give this a try on the Sgi Octane with my self-built audio board. So for this I imported these changes. As far as I remember, my dual processor 195 MHz Octane was decoding FLAC at like maybe 11% CPU usage. So with this 5% faster decoding, maybe we get this down from 11 to just 10% CPU load. Let's see what we get. Not sure if my FLACs are in an OGG container. If that is the case, that may be slightly faster. So let's see if we can measure this on a real world system. The way this optimization works is just optimizing the CRC checking. This is of course interesting. Probably not many people would have thought that the CRC error checking would consume that much CPU. But it makes sense as this audio encoding and decoding is relatively simple. The error checking can take quite a bit of time. So this is optimizing the straightforward table lookup to some slightly more parallelized four-way lookup. The patches are somewhere linked here, so OGG. And here was a link to the original article. And I just grabbed the patches from here. And you see, so this is lame for FLAC, this is this. And as you can see, it is deleting the code for this relatively straightforward CRC ring to some 4 at a time table lookups that potentially can be run in parallel by this modern CPUs. The trade-off is that these tables are, I think, 4 times as large, probably. So let's see how this goes. For this I imported the patches. I only need to check what system I had installed there on the Octane, because I have here multiple builds, T2 trunk, MIPS and MIPS newer, and to check what I ended up installing the other months. And the patches are simply here in package audio FLAC, for example. I just pulled this in here as fast CRC patch and test built this. Of course I could also build this on the Sgi Octane, but certainly on the data center it's faster, so I only need to copy the binary package after this. So let's plug in the Octane and give it a try. So rsync, but not the whole system, only user. So user, that will have the changed files of FLAC, LAME and OGG. There's the documentation. So then let's find the FLAC file. And it's working. You never know with a new build what regression you have with ALSA and X and whatsoever. So I'm still rsyncing here some latest FLACs. So that is playing here, as you can hear. Here, so of course right now we have quite a high CPU load with the rsync, especially over SSH. Anyway, so right now we have SSH, of course 95% encrypting, and SOCKS using 13 to play this. Let's pause this for a second. Of course before I had here nice black box and such, but that's what we get with having a new small minimal system, not going to emerge black box now, just for this. And so let's play something, take a bite, and or what else was nice. This is certainly not a dirty computer, so I'm not going to play that though. But I think I want to listen to something else. Let's see what. So we got some 11%. Okay, so will we even be able to measure that? The other song had interesting, this song has 13% load. 13 to 12. And this song This song really has slightly less load. Interesting. Right now there's mostly bass and some drums happening. Interesting that the load varies already so much with just a different song. So now we need to be careful. So we have established, so Freight has 13 plus minus and Pink has 10 to 11 plus minus. Okay, so now let's rebuild once again the stuff with CRC optimization and see if we see less load. Actually, we could even rebuild this on camera if you're not running out of battery. So logged out from the other one, restore the... So now we have restored this CRC patches. So let's remove the build logs for a rebuild. No socks we don't need. This is OC, FLAC and our name. So let's rebuild. This is on an Epic data center server, obviously, for the build time of it. And then we want to rsync this here. Need to be careful, so I'm rsync. So we rsynced this here, as you can see, with rsync SSH localhost because this is forwarded, and then user source T2 trunk MIPS64 newer build MIPS64 user to user, and this only synced files and user as I don't want to mess the rest of the system. And now let's see, so this are the recompiled binaries with CRC optimization, and let's see what we're getting now. So apparently it's not faster, what a pity, still 10. And this is still 13 to 12% CPU load. That is of course slightly unexpected. I thought I really see a % less CPU load there. I hope you enjoyed this video, showcasting Sgi Octane yet again, and hopefully also learned something. And never trust benchmarks and statistics that you have not falsified yourself. And I hope to see you soon for the next video to come. And my favorite Tori Amos live tour still has the same 11% CPU usage, just like I remembered from the last time. So I wonder if the play of socks has so much overhead. Maybe I pipe it direct into A play 1 second. So that is also down to 7. And that was Pink and the other was Freight, right? Interestingly, this really has a higher load, so this has 9. And you see here the difference. Actually, after all, in total it's not so different, it's just that we have separated out the playing part here. So in total it's still 13, I just realized, having this task separated. And so this was Afraid, so Pink is 7 plus 3 is 10. And that is 8 plus 3. So actually it is after all more or less the same. But maybe let's see, I rebuilt it once more without optimization, and then let's see if we finally see a difference. For final comparison, I also timed here just decoding our favorite cornflake goal song. So that took 30.998 seconds in user space with the optimized version. So once more copying the non-optimized version over, and let's see if we can finally spot the difference. So rebuilding here with the CRC stuff deleted, and then rsyncing here. Certainly way faster to build on an Epic data center server than locally on a 195 MHz MIPS. So you see there's some FLAC and lame stuff scrolling by, so let's give this a final try. Of course, this decoding now takes 100%, as this is not limited by the sound output. It takes a while indeed on the Octane. So for comparison, this took 30.998 in user space, a little bit in the kernel, also IOCTL's reading and writing data. And there, so it is indeed, at least for a single run, slightly faster. How much is this? I don't have euro here. So 30.9 from 31.7. So it is indeed 3% faster, but this looks, I think, slightly less than was claimed. Did they not claim 5 to 10 or something? So that's what we got on the Octane. It's of course a little bit disappointing, the amount of optimization for a news that even made it in Slashdot. That's what you get for the page view driven news reporting of today.